And now let us discuss how the friction value actually varies dependent on the angle of incline theta. Step 1 is to draw the free body diagram of the block. First force acting on the block is mg, weight acting downwards. Then we have normal reaction which is acting perpendicular to the incline. And since the block has a tendency to slide down the incline, friction will act up the incline. Now, in order to further the analysis, we are going to break the mg into two components. So the component of mg which is perpendicular to the incline, that will be mg cos theta, and the component of mg parallel to the incline will be mg sin theta. How are we getting the components? Because consider this angle is theta. Now consider this as a right angle triangle where this angle is 90 degrees. So two angles are theta and 90. So this third angle will be 90 minus theta. Now this purple arrow which I have drawn, this is perpendicular to the incline. So which means this entire angle will be 90 degrees. But we have already deduced that this angle, this small little angle will be 90 minus theta. That would mean this angle over here, the angle between the green and the purple arrow, this is theta. Now since that angle is theta, so this component should have the cos parameter and the other component will have the sine parameter. And in the exam questions, please be very careful about the angles because dependent on where the angle is, you will have to write cos and sine accordingly. Now, remember the concept F net is equal to ma is applied along the direction of acceleration, but perpendicular to the acceleration, we always balance the forces. So normal reaction going up and mg cos theta should be equal to each other. So that's the equation, which we are going to use in the further analysis. Now, till the time the block is at rest, we discussed that the friction acting on the block is static friction. And since the block is at rest, the net force should be zero even along the incline. Mg sine theta acting down the incline should balance the friction going upwards. So mg sine theta is equal to F, where F is the static friction. Now, if you keep increasing this angle theta, as theta keeps on increasing, friction will keep on increasing. And why is that happening? Because friction is mg sine theta. Friction depends on theta. Friction is directly proportional to sine theta. So if theta increases, sine theta will increase and hence friction will also increase. But there is the limit to which the friction can increase, and that maximum value is called limiting friction. And the formula for limiting friction is FL is limiting friction, that is equal to mu L times the normal reaction, where mu L stands for the coefficient of limiting friction or coefficient of static friction, and N is the normal reaction acting on the block. And since this normal reaction is equal to mg cos theta, in this situation, we will write FL is equal to mu L mg cos theta. But please note this FL expression is limiting friction. It is the maximum value of static friction. This much value of friction will be applied on the block when the block is just about to move. And at that angle of inclination, so let's read at this angle, the block is just about to move. And this critical angle has been given a special name. It is called the angle of repose alpha. So let's discuss what is the angle of repose. Angle of repose is the angle of an inclined plane at which the block is just about to move. And let us try to figure out an expression for this angle of repose alpha. So we have the object kept on an incline and this angle theta is just enough so that the block just starts to move. And we had drawn the free body diagram, mg normal reaction. But in this critical case, the friction will be the maximum value of static friction, which is called limiting friction. So till the time the angle theta is small, in that case, friction will be mg sine theta, which we had discussed back in this expression. Mg sine theta is equal to F. So till the time the block is not moving, friction value will increase dependent on the theta. As theta keeps increasing, friction will increase. But at a critical scenario, when the block is just about to move, then the friction value will become mu mg cos theta. So let's say the angle of incline in this situation is alpha, which is called the angle of repose. So what we'll do, first we'll break mg into two components. So like we had done earlier, mg cos alpha and mg sin alpha. Let's balance the forces in a direction perpendicular to the incline. So normal reaction and mg cos alpha should be equal. This is a critical situation where the block is just about to move. So assume the block is still at rest, which means the net force along the incline is approximately zero. So we will write mg sin alpha and friction are equal even in this case. So mg sin alpha is equal to F, where F is the limiting friction and the formula for limiting friction is mu L times N, where N is mg cos alpha. So friction comes out as mu mg cos alpha. Now in the exams and in the books, you can see mu s or mu l, but they mean the same thing, coefficient of static friction. Now we will replace this force of friction with this expression. Hence our equation will become mg sin alpha is equal to mu mg cos alpha. And let us make alpha as the subject. So mg will get cancelled out from both sides. And if we take cos alpha on the left hand side by cross multiplication, we will get sin alpha divided by cos alpha, which is tan alpha. Hence, we get tan alpha is equal to mu s. And if we make alpha as the subject from this expression, we will get tan inverse mu s, where alpha is the angle of repose and mu s is the coefficient of static friction for the surface of the incline. And this alpha is the angle of incline at which the block is just about to slide. Now, if you observe this expression carefully, alpha only depends on one parameter, that is mu s. So let's read. So alpha depends on mu s only, and mu s depends on the type of surface. So depending on the surface of the incline, the angle of repose will be different for different surfaces. But if we are considering a situation where the surface is not being changed, in that case, angle of repose is always a constant. And now let us quickly summarize what we have discussed so far. Look at all these cases where the angle of inclination of the inclined plane keeps on increasing. So dependent on that angle, either the block is at rest or the block is just about to move or the block is actually moving. Depending on that, the friction acting on the block is either static, limiting, or dynamic friction. And we have deduced that the value of alpha when the block is just about to move is called the angle of repose, and the expression for that is tan inverse mu s. And if we go beyond the angle of repose, theta is greater than alpha, then the block is going to accelerate down the inclined plane. So acceleration of the block will only happen if theta, the angle of incline, should be greater than alpha. But in all the previous cases, the block is at rest. The acceleration of the block is equal to 0. So to summarize, just remember the block is going to be stationary if theta falls between this range. Theta needs to be less than or equal to alpha, where alpha is tan inverse mu s. So this is the expression. But the moment we go greater than this angle of alpha, then the block will start to accelerate. Hence, the block will move if the angle of theta is greater than tan inverse of mu s. And these are the rules which we need to use to check whether the block on the incline is it going to accelerate or is it just at rest. But exactly how to approach solving questions like this, questions involving friction kept on an inclined plane. Just follow a couple of steps. Step number 1 is find the angle of repose alpha, which is just tan inverse mu s. In the questions, mu s will be given to us, so we need to find the value of alpha. That's step 1. And step number 2 is just compare the given angle of incline with the angle of repose alpha. In case the angle theta lies between 0 and alpha, then the block is stationary, block is at rest. But if the angle of incline is greater than tan inverse mu s, then the block starts to move.